Hi everyone. Today's session we continue with differentiation. We're gonna look at two rules. The one is when the function is a product of two factors of functions, and the second part if it is a quotient or a fraction of a functions. So let's start with the product rule. So with the rule itself, um, ideally you need to remember the rule. Okay, the more you practice them, hopefully it will sink in and you will remember it. Now those two rules, product and quotient rules, are always given to you in the formula sheet. The last thing you want to do is keep on referring them to them, or you're getting overconfident, you think you know them but you don't apply them properly. Okay, starting with a function, so capital F is a product of two functions f and g. We assume they both, each factor function can be differentiated, so we annotate f prime and g prime the respective derivatives. So the derivative of that function, that should be a capital F prime, by the way, is f of x times g prime of x plus g of x times f prime of x. Okay, I'm going to move on to the other notation, which is the Leibniz notation, which is kind of this is my personal preference. It's kind of easier to remember because it will help you also to remember the quotient rule. So if the function from the left, so we have a different notation, we call it y equals u times v. Both functions can be differentiated, so the derivative of y, which is the left hand side, is equal to u times dv over dx, which is the derivative, plus v times du over dx, which is the derivative of x. I do prefer, let me write that down. Another way you can write it out is saying that this is your y prime. Prime is the notation for the derivative, and what I like is looking at that uv, and I write uv twice. Okay, and the first term we differentiate v, so it's v prime. Okay, and the second term, it's different from the previous order, but I keep u first and then v, is we differentiate u in terms of x, so it's going to be u prime v. Okay, this notation is quite handy to remember the quotient rule. Okay, let's do a few examples. So we need to find the derivative of that function. Now again, you will notice the function, you might need to use also the previous rules that you know. The most common one is going to be the chain rule. None in this example would be in the next ones probably. So here we just name each factor function u and v. We differentiate each one of them. Okay, and we apply the product rule. Again, I will use the Leibniz notation. We replace the each term by their expressions, and what you would do is simplify, so expand and regroup the like terms. Okay, you probably leave it like that, you don't need to factorize. It will be a little bit more, unless it's asking you though. There's an x factor if you wanted to. Hang on, no, it's not finished, so let's continue. Yeah, and yes, if you have a simple factor you can identify, do so. Okay, all right, next example. So you have a product function. We need to find the derivative, so we're going to call so using the other notation, so that's your f of x. We find the derivative. G is going to be that second factor. Now you need to use a chain rule. Okay, so we're gonna call h of x, the first function, the 3x squared plus 2, and the polynomial to the power of 4, we're going to call it h. So using the chain rule, the derivative of g is going to be the derivative of j here of h of x, so you need to substitute that back, times the derivative of h. So we apply that, we simplify the factors, and we end up with that g prime of x. Then we can apply the product rule. Okay, so that's what we know. We have our for f prime, g, and g prime, so we apply the product rule. I know it's time consuming, it's a little bit of working out, but it's a process that you need to be doing yourself. So you substitute the expressions, you simplify here in order to what you could do is expand, but before you expand, try to identify some factors. And here we have that nice 3x squared plus 2. It's the same as here, and the highest common factor will be to the power 3, as this one is to the power 4. So we have that cube expression factorized. We left with that expression, and now that one we can just expand what you have inside and regroup the like terms. Okay, I don't think there's anything else we can do to factorize that one, so that will be it. Alright, another example. So you have product of two functions, sine of x, log of e of x. So you need to allocate a u and v notation, or f and g, depending which notation you use. You differentiate each one of them, and you apply the product rule, and you end up with this answer. Okay, there's nothing here you can factorize, so you can leave it like that. Alright, now we can move on to the quotient rule. Okay, do you remember my handwritten notation for the product rule? I will use the same notation for the quotient rule. Okay, so those are the two notations to express the quotient rule. With the function notation, h of x is a quotient of those two. You can differentiate both of them. The derivative of that quotient is going to be g of x times f prime of x minus f of x times g prime of x over the denominator is g of x, so the denominator of the derivative is going to be the square of that. Okay, now with the Leibniz notation you get the same, a similar expression as before. Now let's go back to what I used before. So y prime is, now this time it's going to be a fraction. Now I'm going to write uv on top twice. Okay, and what I'm going to do is here I'm going to differentiate u, which is going to be u prime. That just remind me I did the rule backwards with the product rule, but that's fine. So do remember here for the first term you need to differentiate u prime, and here you're going to differentiate v, and you put a minus in between. Okay, and the denominator is the function v to the power of 2. Okay, so that is what you should get. Okay, let's do a couple of examples. So you have here h of x, it's a quotient. Okay, you call f of x the numerator, that's x, the derivative is 1. The denominator function is x squared plus 1. You differentiate, that gives you 2x, and you apply the quotient rule. You replace the function by the expression. With the numerator, you need to simplify it by expanding the brackets and regroup the like terms. If you can factorize, you can do so. Here you could factorize the 1 minus x squared, but it won't simplify with the denominator, so probably it's fine to leave it like that. Alright, next one, it's sine of x over e of 6x. E of 6x, you might need to use a chain rule. By using the chain rule, you get a 6 in front, and for each numerator function, denominator function, you differentiate, you apply the quotient rule. With the numerator, notice you have a common factor e of 6x, which is you can factorize, and that simplifies with one factor on the denominator, because it's a square form, it's a factor times itself, and you end up with that nice actually simplified fraction as one factor cancel out. Okay, and that's it for today's session. See ya.